No.
Buongiorno.
Bonjour.
Konnichiwa.
Oh, you're from many different countries. Yes. Okay. So, apparently my smartboard doesn't make it go. Okay. I am Galileo Galilei. You are clapping because the oil of Olay is working, right? Okay, good. All right, so my name is Galileo Galilei, and I like to do experiments. Many people in my day, they did not do the experiments. All that they did was they would go and they would read a book for an answer, and they would read Aristotle. Okay? Aristotle was very revered by the church. So people, they would go ask an authority. So Aristotle, he says some crazy things. He says, women, they are better than men. No, he would not say that. He says, men, they are better than women, because the male horse has more teeth than the female horse. Yet, the horses, they have the same teeth. He didn't even count. He said that a bigger thing has more earth in it than a little thing. So if you drop a bigger thing, it will fall faster than a little thing. See? A bigger rock will fall faster than a little rock. I did not believe this. So I did an experiment. Do you know this building?
Leaning Tower Road.
See, Leaning Tower of Pizza. Yes, Pizza. Leaning Tower of Pizza. See. And it is where I went. So I took a little rock. It's a little rock. Use your imagination. I took a bigger rock. And I went up to the Leaning Tower of Pizza. Oh, no, this is a bad tower. I went up. Move your bum. No, I need your chair. I went up to the Leaning Tower of Pisa, and I take my little rock and my bigger rock, and I lean over the Tower of Pisa, and I drop them. Same time! Wow! Come on, So, Aristotle, he was wrong. And I proved that from experiment. Okay? I did some of the first real science. See? But that is not what the people know me for. What do people know me for?
Telescopes.
Telescope. Tele, far, scope, to see. See? Far seer. See, telescope. Now, I did not invent the telescope. The telescope was already used by sailors. They would look, and they would see other ships from far away. I heard about it, and I looked into the design, and I built my own. Okay? Oh, I forgot. My experiment, you might have said. But what if you drop a feather and a rock? The rock, she fall faster than the feather, no? See? But that is because of the air. If you could drop a feather and a rock with no air, they would fall at the same speed. And people say, you are just talking like a crazy man. There is no place with no air. But my friend, the Mythbusters, they were able to do the experiment for me. See? I bet you did not know that Galileo, I'm having trouble with my own name, Alzheimer's sets in when you are over 400 years old. When 400 years old, you age. Look as good as me. You will not. So, the Mythbusters were my friends, and they did the experiment.
The
really cool thing about a vacuum is that since there's no air resistance, something as light as a feather is going to drop the same rate as something as heavy as a hammer. So, I should be able to put these in the vacuum and see them both hit the ground at the same time if it is a true vacuum.
In my left hand, I have a feather. In my right hand, a hammer.
Commander David Scott carried out his famous test to prove Galileo's hypothesis that all objects are affected equally by gravity. And as Carey explained, with no air resistance, they should fall at the same speed.
How about that? Mr. Galileo was correct.
So, as a control to confirm visually they're working with a vacuum, Carey rigs a clamp to drop them at the same time. And when the guys arrived at NASA in Alabama, the first test they set up for was the hammer and feather rig.
It's good enough. It's not like it's rocket science.
I don't think you can say that around here.
I guess you're right.
Is it your control group?
The team seals the chamber, but for this control, they don't create a vacuum.
Atmospheric pressure in 3, 2, 1.
Cool. The hammer hit first. Perfect.
So the laws of physics still apply. I dropped the hammer and the feather at atmospheric pressure exactly at the same time. Hammer hit first, feather glided down and hit last.
So after the air is removed from the chamber, Carey is ready to repeat the drop.
In 3, 2, 1.
Independent variable is...
That is so cool.
Yep, when there's no air resistance or drag, all objects are equally affected by gravity and fall at the same rate. So we do indeed have a vacuum. Of course, as most of you know, it's not a true vacuum, which in reality is impossible to create. But we did get a partial vacuum of around 10 to the minus 6 torr. A good approximation of what you'd find on the moon. And for more equally bizarre trivia on the missions to the moon, here's Adam and Jamie.
You know, when most people think about...
So they have shown that I was right and Aristotle was wrong. Eh? Aristotle. Huh. So, most people though, they know me from my telescope. Eh? I assigned this one. I'm going to sell it on eBay for lots of money. Eh? So, my telescope I built after looking at the ones from the sailors. So it isn't just the 2 lenses, but I took extra care to make my lenses very, very, very good. So my telescope was very, very, very good. But that is not what made it so special. Do you know what made my telescope so special?
Signature.
Just that movement. Like that. Instead of looking at the ships, I used my telescope to observe the heavens. See? I turned my telescope up. And I saw many things on the night sky. I looked first at the moon. And I wrote about what I saw. The moon, she goes through phases, but even when it's dark, there is still a moon there. Eh? And on the moon, it has the mountains and the seas. It's not a perfect sphere like Aristotle says. Eh? It's the mountains and the valleys, the seas on the moon, and the craters. And I drew many pictures. And I noted how they go through the phases, waxing and waning. See? It's beautiful, no? I looked up at the stars, and I looked into the Milky Way. These are the 3 stars of the Orion's belt. But what to other people with their eye looked like a cloud, I saw was more stars, smaller stars, only stars. See? So I look up, see, Orion's belt. I look at Orion, at the nebula by Orion. It is just more stars, eh? So, then, I look at Jupiter. When I look at the Jupiter, I see, beside the glowing Jupiter, are other stars. What seem to be stars. But they move. Every night, well, not every night, but many nights I record, and they move, and they move, and they move. And the way they move, they must be going around Jupiter. So I name them the Medicean planets, after the Medici family who gives me lots of money. It's better than a billboard, eh? So I name them after them, the Medicean planets. Although now you will call them the Galilean satellites. So, but around Jupiter, not around the Earth. Like Aristotle says everything it does, eh? No. These must be going around Jupiter. See? Not around the Earth. I record and keep many, many, many notes so people cannot doubt what I see. This is how it would appear from my telescope. Look at that. Eh? And then they move. I look at Saturn, and it has strange ears that I could not ever explain. But they are there. This is Saturn on many different days. See? Like that, through my telescope. But not just a point of light. It has a shape, and not just a sphere. Most importantly, I look at Venus. And Venus does not look like just a point of light. Venus looks like that. Like the moon. Like a half a moon. Like the third quarter or first quarter of the moon. See? I record it over many days. Like the moon. See? Like the moon. But it is Venus like the moon. Why does the moon light up that way? Because it is reflecting the sun. So Venus must also be reflecting the sun. Because of where it is and the way it is reflecting, it, like us, must be going around the sun. This means that Copernicus was correct with his heliocentric model, and not Aristotle in his support of Ptolemy's geocentric model. See? I did also look at the sun, and it has many dark spots and bright spots. And I did go blind when I got older.
Okay.
Go figure. Do not ever look at the sun with a telescope. Very bad idea. Oh no. So, has the spots. And I didn't record them. I made the drives. I did discover a planet one time and could not find it again. That I now know was a Neptune. But I only saw it once. It would have looked about it like that. So, I am very excited about what I see, eh? So I share it with other smart people. Most of the smart people, they work for the church. They are the priests. See? So I share with the priests. I even am nice enough, I let them look through my telescope. Okay? I let them see. They see the heavens as I see the heavens. With the sun in the middle. of our universe. And I write a book. And people read my book. And then the church says, we don't like your book. Because my book goes against the
Catholic Church.
You see? So, my book goes against their sainted Aristotle, and they say I am a heretic. I must recant. I must take back my book and say that I have lied. But I have seen it with my own eyes. Can I doubt my eyes? Are my eyes lying? Some of them, they say, there is the devil in my telescope, making me see the bad thing. That is what they say. That is how they say, I must be wrong. And the priest who saw must be wrong. It must be the devil in my telescope. Okay? So, I do not take back my book. I am put under house arrest for the rest of my life. And I die in my house. Yet I am here. Zombie Galileo, here for you. Does anybody have any spare brains? Oh, sorry, I forgot which class I was talking to. No. Thank you, I am here all century. I do not feel obliged to believe that the same God who has endowed us with senses, reason, and intellect has intended us to forego their use, and by some other means to give us knowledge which we can attain by them. We were given eyes, we should use them. We were given brains, we should use them. See? How do we use them? Science and experiments. That is how we know what is true and what is not true. If we do the experiments and look carefully, we know that Ptolemy is a silent P, hey? He probably lived outdoors. Ptolemy made us the geocentric, no, because his P was silent. It's a terrible joke. So, Ptolemy probably gave us the best geocentric model. Not the first, but it is the one supported by Aristotle. Geocentric Earth in the middle is wrong. Copernicus had the correct model, even though the church made him recant what he had said. Though he was kind of smart, he published everything on his deathbed. So he said, okay, come and get me now, church. I'm dying. Smart guy, hey? So, here gives the model that I, with my telescope, showed to be correct. It is not my model. But it still was not quite right with all of the planets in their circles. After me, there was a man named Johannes Kepler who said, not circles, but ellipses. The planets, they do not go in the circle, they go in the ellipse. See? A stretched circle. And because they had such a good model, Sir Isaac Newton was able to make his laws of motion and apply them to the planets. So science grew from the point where we started doing the experiments and looking at the data, looking at what we see, what we measure, and asking ourselves, is this right? And testing it. That is the scientific method. See? Sometimes, using the scientific method to prove that we are right, we make a crazy claim. Albert Einstein, the guy with the crazy hair, okay? He has said, a black hole will bend the light so much that you will see the same star in two places in the sky. He said, this is what would happen. If light is bent, some place in the sky, we will find the same star and see double vision without drinking the alcohol. Hey? So, this star, it puts out the light in every direction. Hey? But what we care about is this direction sucked into the black hole. See? Or is blocked. But just a little to the side, it bends the light. It comes down to me here on Earth. And I see it. Or you will see it. This was much after my time. Right? 350 years later. But on the other side, it does the same. But to me, looking up, it looks to me like the star is here. And it looks to me the exact same star is here. I see it in two places. This was found. Once I predicted this and astronomers looked, Einstein's crazy idea was found. That is a good